Okay, so in this question it says the angle of elevation of the sun is decreasing at 1/6 radians per hour. A building of height 66 meters casts a shadow which is lengthening as the sun goes down. Write an equation, left side, right side equals sun in the middle, relating theta, the angle of elevation of the sun, and x only. X is the length of the building's shadow. Ooh, so a good picture would be nice. Let's do it. How can I should I do it down here? So let's maybe I can squeeze it in over here. All right, so what do we got going on? We have got maybe better do it right here. We have got building in the ground. Let me shrink this down a bit. So we got some building. And we got the sun up here in the sky. Oops. Get off the tool there. So here, get the sun up there in the sky shining. And it shines on down like that onto the ground, and it makes a shadow. This is the building over here, right? Some big old building, right? And then the sun shines, and there's a shadow on the ground. Okay, and they're talking about what are they talking about? Um, the building of height 66 meters casts a shadow. So the building is 66 meters high. Here's an angle theta. What's that? Um, the theta, the angle of elevation of the sun. So an angle of elevation, you really got to know that concept, is from flat up to something. So that's how I knew theta was right there. Angle of elevation means how far it's elevated from flat. So you take flat ground, this is the ground down here, and you go up, up, up until you're aiming at the sun. That's the angle of elevation. Okay. So I need theta, and then it says x is the length of the building's shadow. Okay. So let's put that in play as well. So x goes from here to there, doesn't it? Okay. So there we go. So now there's a little picture of what's happening. And as the sun gets lower and lower, then the shadows get longer and longer, don't they? So it's talking about as the sun goes down, the shadows get long. Okay, what's the connection? Well, you can see it right here. Tangent of theta is 66 over x. They want a connection between theta and x. How do we know it was tangent? Remember SOHCAHTOA? From your trig days, your glorious trig days, right? So from theta's perspective, the side right here is the opposite. This side right here is the hypotenuse, and this side, therefore, must be the adjacent. Remember all that stuff? Let me get rid of these from the middle so it's not confusing our picture too badly. So, yeah, ground back in there. So, okay, yeah, so this is the opposite side. This is the hypotenuse across from the right angle. This must be the adjacent. So we have an x and a 66, which are adjacent and opposite. Which trig function uses adjacent and opposite? Tangent. That's how we know. So we want tangent of theta equals 66 over x because that's opposite over adjacent, right? That's what tangent is, opposite over adjacent. 66 over x. So there's our first answer, first equation. That's equation relating those two, right? We're doing related rates. Okay, when the angle of elevation of the sun is pi over 5, what is x? Oh, well, we can take this little equation and we can solve for x, can't we? Just put this over 1, go diagonal, diagonal. We get x tan theta is 1 times 66. And finish solving for x. We're trying to find x, which would be divided by the tan of theta. Boom, boom. So there we got x. X is 66 over tan theta. And they're telling us the theta is pi over 5. So it'll be 66 over tan pi over 5. Let's go to Desmos. 66 over tan pi over 5. 66 over tan. Whoop, I think tan pi over 5. Boom. Notice degree mode, you got to be in radian, right? Always radians in calculus. So what do we got? 90.8412. Is that right? 90.8412. Yeah, looking good. 90.8412. Got it. Okay, so we got X. That's X. That's how long the shadow is when the angle of the sun is pi over 5. Now, last question. How fast? There's my rate question. How fast is the shadow cast by the building lengthening at that time? Okay, so let's go back. We got to go back to this equation right here. Tangent theta equals, and I'm going to write it 66x to the minus 1 because I don't want x being part of a fraction, right? Because that means quotient rule, and I hate the quotient rule. I'm going to avoid that. So make it like this, make your life so much easier. All right, so you know what we need to do. You know how related rates go, right? So step number 1, you have to identify, well, here, let me write step number 1 up here. Whenever we do related rates, step 1 is you identify, or let's just say find, such a fancy word. Just find them. Just find the rate letters. So which letters in this problem talk about rates? How fast is the shadow? So that's dx dt, lengthening. That's the change in x, right? X is the shadow's length. That's dx dt. What other rates did I talk about? Theta, da da da. Oh wait, I think of the words. The angle of elevation of the sun is decreasing. There it is. Angle of elevation of the sun. So that's d theta dt. So we want to find dx dt. D theta dt is what? It's decreasing. So it's negative 1/6. The change in theta over time, right? The angle is going down. The angle's getting smaller, negative. Whenever we decrease, that's always the size is going down, negative change. When something's decreasing, its size is going down, negative. If something's increasing, size is going up. So that's negative 1/6. That's d theta dt. So I'm just looking at what they speak of. There it is. So now I'm going to take the derivative. So that's step 1. Step 2 is the equation with those letters only. And we've got that, right? I mean, what letters? X and theta and X. And then numbers are fine. Only those letters, no other letters. Got it? That's right there. And then step 3, d dt, both sides. So I'm going to come in here and go d dt, d dt. What's the derivative of tangent? Secant squared theta times d theta dt because of the chain rule, right? None of these letters are t, even x. We're going to do the chain rule. Why? Because we're doing dt on the bottom, not dx. So everybody's going to have chain rule action. So this is 66. Oh, wait, no, it's negative 66x to the minus 2, right? That negative one comes down times, but he's got chain rule action too because, again, he's not t. Whenever you take the derivative with a different letter on the bottom than the letter involved in the function, you got to do the chain rule. Okay, so now what are we trying to find? D theta dt. So step 4, plug in the numbers. So we did the d dt to both sides. Now we're going to plug in. Again, we want to find dx. So we want this. Oops, let me change the color. We want this guy. That's what we want. We want dx dt. That's what they're asking for. Right? How fast is the shadow lengthening? Dx, change in x. X is the shadow length. Dx dt. How are we going to do that? Okay, well, not easy. Gonna have to make this 1 over cosine squared. You remember that? Secant is 1 over cosine. Remember sine, cosine, tangent. Remember your trig. Gotta remember your trig in calculus. If we flip those guys, flip, it's cosecant secant, cotan, flip, flip, flip. So cosine and secant are flips of each other. So secant squared is 1 over cosine squared times, now d theta dt, we got that right here, minus 1/6. So that's going to be minus 1/6 equals negative 66x. What is x? Do we know x? Oh yeah, we found x back here. That's the 90.8412. I better move on. 90.841207 to the minus 2, and then dx dt. The xt is what we're trying to find. So the only thing I don't have there is theta. Do I know theta? How am I going to get the cosine of theta? Yikes. I don't know. How can I get that? Well, let's do this. I think we can do it. To make life a little bit easier here, I want you to notice that both these guys, um, yeah, here we go. I'm going to divide this side by minus the minus 66 and the 90.841207 just to get rid of these guys, right? And whatever I do to one, I can do the other. But let me tell you how it's going to work. Do it over here too, right? I'm going to divide by, well, let me just do it simple. So 90.84.841207. Okay. And let's make those two negatives both positive. Huh? Two negatives make positive. So all I need is to plug in theta. What in the world is theta? Well, right here. We got this equation right. Um, uh-oh. Not sure we had it. Where's that little um thing? Tangent theta. Oh, theta, there it is. Theta. No, 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 no. No, that's the change in theta. Yeah. Okay. So I guess we have to, I'm looking for something easy. There's nothing easy. So for theta, I'm gonna have to do this relationship right here. So I've got tangent of theta equals 1.66, sorry, is 66 over x, right? Just grabbing that right there. 66 over x. So that means if I tan inverse both sides, the boom boom, theta is tan inverse of 66 over x. And I know what x is. Why? Got it right here. Um, oh, wait a minute. I'm sorry. This is ridiculous. I'm being ridiculous. We know theta. It's pi over 5. All right, I was just doing something way harder than was needed. Right there. I thought I'd seen it. Right there. The angle of elevation of the sun is pi over 5. Let me write that. Theta, the angle, is pi over 5. So let's pop that bad boy in there. Right there. Pi over 5. Good. To Desmos we go. All right, 1 over cosine squared, pi over 5. Let's go. 1 over cosine squared. So I'm going to go fraction, 1 over cosine. Wait, let me back up. I have to square this. Boom, cosine, pi over 5. Pi over 5. Pi over 5, please. Squared. Okay. Let's go back. 1 over cosine, pi over 5 squared times 1/6 over 66 times 1/6. Go forward. Times 1 divided by 6 over times 1/6 over the 66 times that 90 number. 66 times that 9 is 66 times. Now that 90 number is still on my screen. It's the last answer. I use the answer button from Desmos. Boom, there we go. Now I'm getting 4.24723. 4.247. So 4.24743 times 10 to the minus 5. Is that right? 24743, 24743, 24723, 24723, 24723. Anyway, times 10 to the minus 5. What does that mean? That means you got to take this decimal, get back 1, and you're to the edge, 2, 3, 4, 5. Brings in zeros. Ends up right there. So it's 0.000424723. That is dx dt. Is that what we got? Not even close. Not even close. What did we do wrong? Ooh, that's revolt and development. Let me see here. How fast is the shadow? Um, got x, great. Came on down with the equation. Tangent theta 66 over x. And then minus x minus 2. Oh, I forgot to square this guy, didn't I? I forgot to put minus 2 power on that guy. Look at that. I forgot about that minus 2 power. Let's try that one more time. Just forgot that little, there's a lot to remember here. Let's go back, put that in decimals, a little minus 2 power. Right there, right there. Uh, wait, is it minus 2 power on the bottom? Is that what it is? Yeah, minus 2 power on the bottom. All right, all right, all right. To the power minus 2. Boom. 31.8386. 31.8386. Yes, there it is. Messy business, but we did eventually get it. There it is. So that is correct.